Hi, my name is Charlie Blanco. I'm here with my group mates Aaron Anderson, Nick Bello, and Matt Pinella. The four of us have spent this semester in the Civil Engineering Structures Capstone, where we were given an assignment to design a building in its structural design. We were given 16 different criteria from SpaceX to design a hangar and office space building for their expansion in Titusville, Florida. This building had several requirements associated with the end product, including a 45-foot by 100-foot office space and the rest of the building devoted to a hangar with an internal crane. Designing this building will be explained by the rest of my group members.
To start out the design, we decided to try several different types of trusses, and we applied preliminary loading to each of them. After going through each of them, we decided that the sloping truss was actually the lightest when considering these loads. As a result, we are then able to use this truss in the SAP 2000 model and apply live load, dead load, and wind load as calculated by our group members. From this, we were able to gather loading and design the members, which Aaron will talk about.
So we went through designing the members based on the loading that Nick just described. And so a lot of our different controlling members were made through flexure, block shear, compression, and tension members. And these controlling members were decided based on the amount of loading that was applied to these members based on the types of loading combinations that were applied. So the one big thing that we had to take into consideration was that all of the columns were considered beam columns, and this was due to the large axial force from the dead weight of the members above it, but also the large moments applied from the wind loading on the structure. But going through, after we designed all these members, we were able to do an iteration in our SAP model. So we put in our new member sections and were able to recalculate all of our dead loads. And from this redesign, we were able to see that all of our initial members that we had designed were able to be sufficient. And then we moved into our connection and foundation.
Following our redesign, connections were designed for key components of our structure, such as beams to girders, columns to lateral bracing, and within our trussing system. Various limit states were checked within our connections, such as block shear. Our foundations were designed as spread footings due to the well-drained, dense sand soil property of the location of our structure. And here's Charlie to talk about challenges.
This capstone design class was our first experience for all of us as group members doing a design of a structure from start to finish. Understandably, there were challenges we faced along the way. One of the most clear of these challenges was incorporating manufacturer-specified items like the overhead crane into our design components and making them mesh. Lastly was the geometry and complex connections. As we started to refine the resolution of our CAD drawings, we started to find some issues, but we were able to address these with the types of connections we used by using splice plates, gusset plates, and the like. Thank you for taking a look at our project today.